Okay, moles. Yesterday we started this topic. How we define the term mole? Mole means it is amount of substance which contain Avogadro's number of the particle, which is 6 into 10 raised to power 23. So if any amount of a substance which contain 6 exponent 23 particles, we call that as a mole of a substance. And yesterday I explained, like, whenever you have 1 mole of any substance, it will have 6 exponent 23 particles. But 1 mole of a gas at STP means standard temperature and pressure, it will occupy 24 decimeter cube. This is a volume which is occupied by 1 mole of any gas. And mole, to understand, if you want to understand simply what is mole, you can understand that mole is atomic mass or molecular mass expressed in gram. So atomic mass or molecular mass expressed in gram, we call that as a mole. Now for moles, there are formulas and there are ratios as well. First, the formulas for mole. The first formula, moles is equals to mass in gram divided by atomic mass or molecular mass, because it depends on whether we have atom or molecule. So according to that, so mole is equals to mass in gram divided by atomic mass or molecular mass. The second formula for moles is equals to volume of the gas in decimeter cube divided by 24. So if volume of the gas in decimeter cube divided by 24, will also get the moles. The third formula, moles is equals to number of the particles divided by Avogadro's number, which is 6 into 10 power 23. And the fourth formula for moles is equals to concentration of the solution multiplied by volume of solution in dm cube. So these are the 4 formulas which you have to keep in mind when you are solving a question related to moles. Moles equal mass in gram divided by atomic mass or molecular mass. Moles equal volume of a gas in dm cube divided by 24. Moles equal number of the particles divided by 6 exponent 23, Avogadro's number, or moles is equals to concentration of the solution equal multiplied by volume of solution in dm cube. Copy these formulas. I will give you example of each formula so you will understand how you can find the moles.
Sir, we can use all of.
Uh, it depends on, because sometime if mass is given, then you will use the first formula. If volume, If gas volume of a gas is given, you will use the second formula. So it depends on the question, like what information is given. According to what is given, you will use that formula. All four formulas cannot be used for one question.
These formulas. Okay.
So, example, the question related to the first formula, which is moles equal to mass in gram divided by atomic or molecular mass. Because it depends on whether a substance is an atom, then atomic mass. If it's a molecule, then it will be a molecular mass. Example, if a question is find moles in 46 grams of sodium. So you want to find moles in 46 gram of sodium. So the formula moles equal mass in gram divided by atomic mass or molecular mass. But as we know, sodium exists as an atom, like the metal is there. So it will substitute atomic mass. So moles equal, so you have to use the periodic table for this. Moles equal mass in gram divided by atomic mass. So mass in gram is given for sodium, it's 46, that's given. Atomic mass of sodium, when you check the periodic table, in exam, the periodic table will be there. So you have to use that periodic table to work out the mass. So when you check for sodium, the position of sodium, this is a position of the sodium. So you can see atomic number is 11, atomic mass is 23. In this Cambridge IGCSE, you can see atomic numbers are top and atomic mass are at the bottom. So it is 23. So when you substitute, you will substitute 23. So 46 divided by 23, that's equal to 2. And the unit is mole, MOL. Means the unit of the mole is also mole. But we don't write MOLE, we just write MOL. So it is 2 moles. Is it clear? Is it clear, this one? If the question is find moles in 50 grams of calcium carbonate, So moles in 50 grams of calcium carbonate. So the formula for calcium carbonate is CaCO3. Moles equal mass in gram divided by, in this case I will write molecular mass. Why because calcium carbonate is a molecule. So we will write a molecular mass. Mass in gram is given 50. But what about molecular mass? So here you have to find the molecular mass. How to find a molecular mass? You have to again use a periodic table. Calcium is 40 plus carbon is 12 plus oxygen is 16 multiplied by 3. So 40 plus 12, 52. 52, 16 multiplied by 3, 48. 52 plus 48, 100. So that will be equal to 100. So moles equal 50 divided by 100. That's equal to 0.5 mole. Is it clear the first formula? How we use the first formula? Yes, Salman, that's right. 0.5 is the answer. The second formula in which moles equal volume of a gas in dm cube divided by 24. But it should be a gas, like volume of a gas divided by 20 in dm cube divided by 24. What you will get? You will get moles. So if a question is find moles of oxygen, moles if in 30 or 300 cm cube of oxygen gas. So the formula moles equal volume of a gas in dm cube divided by 24. But you don't have dm cube, you have cm cube. So how to convert cm cube into dm cube? You will divide by 1000. No, it's divided by 1000. Why it's divided by 1000? Because it is cube. When you are converting centimeter into decimeter, you are dividing by 1000, dividing by 10. But you are converting centimeter cube into decimeter cube, so you'll divide by 10 cube. 10 cube means 1000. 10 multiplied by 10 multiplied by 10. So whenever centimeter cube into decimeter cube, you'll divide by 1000. So first thing, the volume is in cm cube. We have to convert into dm cube. So divide by 1000. That makes 0.3 dm cube. Now you will use the formula to get the moles. What's the formula for moles of a gas? If the volume is given, volume of the gas in decimeter cube divided by 24. 0.3 divided by 24. What's the answer? 0.0125. And that is mole, MOL. Another question, if the question is, find moles of in 60 dm cube nitrogen gas. Yeah, what will be the answer? If you need a moles for nitrogen, the formula moles equal volume of gas in dm cube divided by 24. 2.5 moles. So it will be 60 divided by 24 equal 2.5 moles. The third formula, in which moles equal number of particle divided by Avogadro's number, you don't find very common questions related to this formula, but I'll give an example. Like if a question is find moles present in 3 into 10's power 23 molecules of hydrogen. So we have the particle and we need the mole. So how to find moles from the number of the particle? The formula is moles equal number of the particle. Particle can be atom, molecule, ions, divided by Avogadro's number, which is 6 into 10's power 23. So this will be 3 into 10's power 23 divided by 6 into 10's power 23. What's the answer? 3 exponent 23 divided by 6 exponent 23. So it will be 0.5 or a half mole. So 0.5 mole will be there. So this formula, you don't find a question in O levels. Normally they're not asking this formula. The last formula, in which moles equal concentration of the solution multiplied by volume of solution in dm3. This formula is normally used for acids to find moles of acid, moles of alkali, or moles of salt present in the solution. So concentration of the solution multiplied by volume of solution in dm3. Example, if I say find moles of NaOH, sodium hydroxide, of concentration 2.5 mole per dm cube and volume 30 cm cube. So we need the total moles of sodium hydroxide present. Look, the concentration means how many moles are there present in 1 dm cube. So you can also use the ratio to solve this question. Like you can also simplify this. You can say the ratio between mole and volume, because the concentration 2.5 means that there are 2.5 moles in 1 dm cube. So how many moles will be there in 30 cm cube is there? When you convert into dm cube, it will be 0.03. Then this will be x. Cross multiply, you will get the answer. This is one way. Or the second one, you can use a formula, concentration multiplied by volume. So concentration is 2.5 multiplied by volume is 30, but that is 30 cm cube. You will divide by 1000 to convert into dm cube. So 2.5 multiplied by 0.03. What's the answer? 2.5 times 0.03. What's the answer? 0.075. So 0.075 mole. Is it clear? The formulas for the moles.
Yes, sir. It's clear.
But in exam, you have a question in which you have to use a formula and the ratio. Here, these are the 4 formulas. You have to go through these formulas and just use the formula according to the question and get the answer. But normally in exam, you find question related to moles. An equation is given. So when the equation is given, we can use ratio to find moles, to find mass, to find volume. How it can be done? Example, if there's an equation calcium carbonate decompose into calcium oxide plus carbon dioxide. And the question is find moles of calcium oxide formed by 3 moles of calcium carbonate. So find moles of calcium oxide formed by 3 moles of calcium carbonate. So we need moles of calcium oxide and we have the moles of calcium carbonate. So what we can use the equation and work out this value. So calcium carbonate is there and calcium oxide. What we will do, because moles are given, we'll take the mole ratio. What is the mole number? The number which is written before the compound or element in an equation, that's called a mole number. So if nothing is written, it means it is 1. So what is how many moles of calcium are there in the equation? That's 1.
1.
How many moles of calcium oxide are there according to equation? 1. So means the ratio of the mole is 1:1. If there is 1 mole of calcium carbonate, there should be 1 mole of calcium oxide. But how many moles are there in the question?
3.
So if you have 3 moles of calcium carbonate, how many moles of calcium oxide will be there? X
3.
cross multiply. Yeah, the final answer will be 3, but X cross multiply, you will get the moles as 3. So we got 3 moles of calcium oxide. So first we take a simplest ratio from the equation, and using the equation we worked out how many moles will be there according to the question. So if moles are given, we'll take the mole ratio. But if mass is given, for example, if the same question was there, find mass of calcium oxide produced by 25 grams of calcium carbonate. So if mass is given, then I have to take the mass ratio. What is the total mass of calcium carbonate? Here, if I will always take use the equation for the ratio. What is the total mass of calcium carbonate when we worked out, like the molecular mass? That will be 100. So this will be 100. What is the total mass of calcium oxide? Calcium is 40 and oxygen is 16. What is the total mass of calcium oxide? So it will be 56. So the ratio is 100 is to 56. If 100 is to 56, but in the question we don't have 100. First, we always take the simplest ratio from equation and then we will solve according to the question. But in the question, we have only 25. So if we have 25, how much calcium oxide will be there? X. Cross multiply. So if you need moles, you will take the mole ratio. If you so 25 into 56 divided by 100, what's the answer? 56, 28, 14. So it will be 25 into 56 divided by 100. That's equal to 14 grams. Is it clear? 14 grams. So normally you will find a question in which you are using an equation and using a ratio of the moles or the mass, or it can be for volume also. But volume ratio is only valid for gases. When there are gases, then there is a volume ratio. If there is no gas, then you cannot take the volume ratio. Copy this example. So more examples I will give related to the moles. Moles, because I told you moles, it required only practice. Like once you understand the technique, how to solve a question, you just have to practice different types of questions. So we discuss the formulas today and the ratios. Next class, we will solve questions related to moles chapter. There are only two ways to solve the question. One is by formula and another one is by ratio. If moles are given, you take the mole ratio. If mass is given, take the mass ratio. If volume is given, take the volume ratio. Any doubt related to the class?
No, sir.
Okay. So I'll end the session and share the recording with you.